Hey everyone! The job of a front-end engineer has just completely transformed over the last few years. We're way past just making websites look pretty. Now, it's all about engineering these incredibly complex, scalable applications that live and breathe right inside the browser. So, what does it really mean to be a senior front-end engineer heading into 2025? Let's get into it. This quote right here, it just hits the nail on the head. This is the perfect way to frame our whole conversation. The bar has moved. It's not about, hey, can you write a simple function? Anymore, it's about, can you design a system that can handle millions of users without breaking a sweat? It's a huge shift from being just a coder to being a true architect. All right, so let's pull back the curtain. How do the top companies, the ones you really want to work for, how do they measure this new level of seniority? Well, it's definitely not just one thing. They're looking at you through a much wider lens, a competency model that goes way, way beyond just your coding skills. At the very top, your expertise gets broken down across these four pillars. First, you've got to have a deep, almost intuitive mastery of the JavaScript runtime itself. Second, you need an architectural level grasp of your main framework, something like React. Third, you're expected to design large-scale front-end systems. And last but not least, a relentless focus on what's called operational excellence. Now look, all four of these are absolutely vital, but for our deep dive today, we're going to laser focus on three of them: the JS runtime, system design, and that critical commitment to operational excellence. So let's start with that first pillar, really mastering the JavaScript engine. This is all about popping the hood and truly understanding what's happening when the browser actually executes your code. So what's the biggest giveaway? The number one thing that separates a mid-level dev from a senior? It's not about knowing some obscure new API. Nope. It's a deep, granular understanding of how JavaScript handles asynchronous concurrency, which is kind of crazy when you remember it's a single-threaded language, right? And the absolute heart of that whole concurrency model is the event loop. Think of it like the engine's conductor, orchestrating this beautiful symphony of code. A senior engineer doesn't just know it exists. They can actually visualize how it juggles work between the main call stack and its two very different kinds of queues. Okay, now this is where it gets really interesting. It all comes down to priority. Microtasks, like what happens after a promise resolves, they're the VIPs. They get to cut the line. The engine will run every single one of them before it even thinks about looking at a macro task or updating the UI. And knowing this one detail is absolutely mission critical for performance and, not freezing up the user's screen. This little snippet of code, it's a classic in senior interviews, and for very good reason. It's the perfect test of this deep knowledge. Seriously, pause for a second and try to guess the output. In what exact order are these messages going to show up in the console? So let's trace it. Start and end are synchronous. They go straight to the call stack and fire immediately. Easy enough. The set timeout, even with a 0-millisecond delay, gets kicked over to the macro task queue. The promise? It goes to the micro task queue. Now, once the call stack is empty, the event loop looks for the VIPs first. It finds promise 1, runs it, which immediately puts promise 2 right back into the microtask queue. So it runs that too. Only after that VIP queue is totally empty, does it finally go back and process timeout 1 from the macrotask. And the reason this level of detail is so important goes back to this history right here. The original JavaScript engine from way back in '95 was, it was simple. But everything changed in 2008 when Google dropped the V8 engine. It kicked off this massive arms race in performance with amazing innovations like just-in-time compilation. This whole battle is what turned JavaScript into the high-performance powerhouse it is today, where these tiny internal mechanics have a huge impact on application speed. This table is such a perfect example. It shows that even a question that seems basic requires a much deeper, more nuanced answer at the senior level. A junior developer will tell you about scope, but a senior engineer, they're talking about the subtle differences in hoisting, the temporal dead zone, the rules around redeclaration, and how it all interacts with the global window object. It's all about precision and completeness. Okay, so mastering the engine is the bedrock, right? It's the foundation. Now let's build on that and move to the next pillar. We're going to zoom out from the nitty-gritty of the language to the grand architecture of the applications we build with it. Look, any competent developer can build a really solid self-contained component. It fetches some data, it renders the UI, it handles its own state. This is the fundamental building block of modern front-end. It's table stakes. But a senior engineer, they're thinking at this level. They aren't just building the individual bricks, they're designing the entire city plan. They're architecting systems that let multiple teams, the feed team, the profile team, the stories team, all work on different parts of the app at the same time, without constantly tripping over each other. And that whole approach has a name. It's called a micro front-end architecture. The big idea is to chop up a giant monolithic front-end application into these smaller, independently deployable pieces that all come together to feel like one single, seamless product to the user. And here's the crucial part. It's all about understanding the trade-offs. A monolith, on the left, it's great for small projects. It's simple, but it quickly becomes a huge bottleneck when you try to scale your teams. Micro front ends, on the other hand, they give teams autonomy and let them deploy whenever they want, which is a lifesaver for big orgs. But they definitely add their own complexity. Seniority is all about knowing which tool to use for which job and when. So you can have the fastest engine and the most scalable architecture in the world, but it means nothing if the final product is slow, buggy, or just feels clunky to an actual human being. And that brings us to our third pillar, operational excellence. In 2025, the user experience is basically measured by Google's core web vitals, and these are totally non-negotiable. A senior engineer doesn't just know about them, they are directly responsible for how the application performs on these metrics. We're talking LCP for loading speed, INP for how responsive it feels, and CLS, which is all about making sure the page doesn't jump around. You don't just ship the feature, you own its performance out in the real world. And delivering that kind of performance means you need deep knowledge of your entire tool chain. For example, you have to understand why a modern tool like Vite is so much faster for development than a traditional bundler like Webpack. The secret is that Vite uses native browser features to serve files only when they're requested, which leads to these almost instant server start times. That's knowledge that makes a difference for both your team's speed and the final product. So we've talked about the engine, the architecture, and the end user experience. But what's the glue that holds all these technical skills together? Well, it's a fundamental shift in your mindset. See, seniority isn't about memorizing a checklist of technologies. It's about having the wisdom to navigate the really tough trade-offs that pop up every single day. Do you chase that last millisecond of performance, or do you make it easier for your team to ship faster? Do you enforce a rigid, consistent design system, or do you give teams the freedom to experiment? A senior engineer's real value is their ability to make these tough judgment calls, day in and day out. And underneath every single one of those decisions is the final, ultimate gatekeeper, security. It is an absolute mandatory requirement for a senior engineer to have a deep, practical understanding of common web vulnerabilities, like cross-site scripting or XSS and cross-site request forgery, CSRF. And not just know about them, but know how to build defenses against them right into the core architecture of the application. And that really brings us to our final thought here. The leap from a mid-level to a senior engineer is a really profound shift in perspective. It's about moving past the day-to-day task of building one more feature and starting to take on the much bigger responsibility of architecting systems that are resilient, performant, and secure. It's about asking yourself, are you just closing tickets, or are you truly engineering the future of the application?